Thanks. This is Eunhyeuk Kim from Korea Aerospace Research Institute of South Korea, and before starting the talk, I'd like to thank Krista and Greg for inviting me for this wonderful meeting and have an opportunity to introduce KPower Mission to the expertise from the world on the lunar exploration. So this slide showed overall space exploration plan of South Korea, starting from the page 1 is to sending lunar orbiter, which is KPLO. KPLO, the acronym of the Korea Pathfinder Lunar Orbiter, and recently has a new name of South Korea called Danuri, means that they enjoy all the things of the moon, for example. That is the meaning of this word. And second phase is sending a lunar lander. Is going to happen in the early 2030, and pre-phase study is now ongoing, and hoping that the mission is initiated from next year. And with successful of these two missions, we're hoping to continue our study on the space exploration into the more deeper states, for example, Mars and asteroid. And so those are the initial plan of South Korea in the next 10 to 15 years. And every 5 years, South Korea renewed this space plan, so there is a little bit more adjustment afterward. So first, I to focus on our KPLO mission. It is South Korea's first space exploration mission, and it was initiated from 2016, and it's supposed to be launched by 2022. So some of the personnel at the conference might know that the spacecraft is already in the launch site, and launch campaign is initiated from the early of this month. So as far as I know, that launch is going to happen the 2nd of August, and so far, everything is going well because I was at the launch campaign period as well. I'm coming back to South Korea 2 days ago. And so far, we found that there is nothing wrong with the spacecraft, and fueling to the spacecraft is ongoing. And after that, there will be some more job to putting the spacecraft in the launch vehicle, and then it's go out to the space. So things are going well. And then the mission lifetime is 1 year at the lunar. So basically, is not a long mission at all. So we have 6 payload, 5 scientific and 1 technical payload. So basic idea for this mission is technology development and demonstration. Also using the science instrument, we are hoping to gather some more visual data of the lunar surface. So these are the basic science mission objective. So because this is the first in South Korea for the space mission, so we want to develop the critical technology for the further space exploration, as well as the science investigation of the moon environment. And also, we adopt some new technology, and then we want to realize and validate those new technology on the moon. So here goes some heliocentric view of the KPower mission. So in the center there is a sun, and we have Earth orbiting the sun, and the small circle around the Earth is the moon orbit. So the launch is happening the 2nd of August, but there are some launch period depending on some situation. You might have launch at the same day, so that we have reserved some launch period. Afterward, there is a TS phase. It means that TS translunar cruise phase happening until the middle of December, and then we put the spacecraft into the lunar orbit called LOA. It's called the Lunar Orbit or Acquisition phase. So basically, we hope that spacecraft can be captured to lunar gravity at the start of the new year, next year, and we will have the 1 month of commissioning phase. During that commissioning phase, most of the instrument will be well calibrated. We hope that then they are ready to go for the science, and then the spacecraft operate all the payload in the nominal mission phase from the starting of the February 2023 until the end of the year. But until the end of the year, so depending on the how much fuel left, we might think about that, whether we're able to continue the mission, so-called extended mission phase. But that is critical with the remaining fuel we have. So it is still, we don't know yet, because we don't know how much fuel is going to be used, the LOA phase and so on. So this shows the overall structure of the spacecraft. As if you look at the left-hand side, it is the stored configuration inside the payload of this launch vehicle. And this, at the size, you can hear that a little bigger than the human height. So it's not a big spacecraft. And if you look at the right-hand side is the configuration in the operational mode. So solar panels are deployed, and antennas and magnetic boom was also deployed as well. Here show that the launch is going to happening at the Cape Canaveral space launch facilities of the Florida, and that launch vehicle is Falcon 9. And if you look at the launch vehicle payload, so pairing is quite big compared to the size of the launch of the KPLO. So I'm showing the short video clip how the launch is happening. So far, we believe that a spacecraft is launched at the Cape Canaveral Space Launch Vehicle Space Launch Complex 40 at the night of the evening of the August 2nd in local time, and after the couple of tenths of the minute, and that there will be separate from the satellite as a space launch vehicle, and the satellite is heading to this predefined trajectory to the moon. Yes. So this is the, we try to prepare this video clip as real as possible. So actually, as colors and everything in the video is actually a real spacecraft. This showed how we developed the ground station, because this is first time to South Korea. We developed everything. So not only for the spacecraft, but also ground station, which serve for the commanding center of the spacecraft. So in this slide, the central box is the Kari properties. So we are developing all the stuff inside. But as you understand that this mission is not just a mission by Korea, but also there is a close relationship and cooperation between Kari and NASA of the United States. So we have some connection interface between NASA TSN antennas, NASA FOD in Johnson Space Center, and NAVE, which used for the data format of the spacecraft data is coming from JPL and NIFE. And also there are a couple of science operations of the payload. The 4 of them is South Korea, and 1 of them is Arizona State University, which developed the shadow cam. Those are payload information will be described in the later. Also, we developed the deep space antenna. This is 35-meter with aperture size of 35 meters, and it has key services expand uplink to downlink, and expert downlink is also available. But we're hoping to in the future to expand uplink. K-band extension is going to be another topic. We are working for that. So those are the service items. So I just show simply how this development is happening in video clip. There are some Korean letters, but doesn't matter, I guess. So right now the antenna is all set up. So we have tested the antenna with several missions, not just from South Korea, but also NASA, because we have collaboration with NASA. So they provide us to some information. So we are able to track the data from some satellite. So it turned out that the ground station works quite well. So it's ready to support the mission soon. And to show that how we are heading to the moon. So probably some of the guys knew that the KPLO has some different trajectory called BLT. BLT is called Ballistic Lunar Transport Trajectory. It takes a lot more time compared to the conventional way, for example, Apollo or phasing loop trajectory, something like that. So basically it takes about as long as 4 months. But the advantage of this technique is to save fuel so that you are able to move fuel during the mission orbit. So if you show a little bit further, then if you look at the orbit in the Earth-centered initial frame, it looks like this one, the upper left-hand side. But if you look at this trajectory in the rotating frame, that is we are working already shown that. If you look at the side view, it's almost like the elliptical plane. So one of the good point is that depending on the launch date, I mean, this is Earth, and depending on the launch date, if you launch August 2nd, then maybe it's called early launch, and then spacecraft take this route. But for the case of if you are able not to launch at the day, so if we launch in late time, it's going to take called late launch. Then at different times, that it means that regardless of the launch date, the time to the arriving the moon is the same. So we're hoping that a spacecraft will arrive at the moon of the mid of the December, with regardless of when the spacecraft launched. So this is one of the good example, one of the good point for the why you take the BLT trajectory, because we are able to adjust the time so that we are fixing up the time for the operation of the spacecraft on the moon. So this is how a spacecraft looks like. It's quite similar to the real shape of the spacecraft. So there are 6 payloads. For example, the total mass is 678 kilogram, and then dry mass is about more than 200. So there are shadow cam is going to be was developed by the Arizona State University on the contract with the NASA. So it is aimed to study the common shadow region, which is supposed to have a lot of the water and volatile element, both in South Pole and North Pole. And also we have wide-angle polarimetric cameras, and it is Korean payload, and to aim to map the whole lunar surface in the polarimetric map. So the surprise by the know that only the near side of the moon has been observed in polarimetric manner, but with this camera we are able to map not only the near side but also far side of the moon. So it's going to be provide a lot of interesting information on the moon, soil, and space weathering process. And also we have lunar terrain image called Luri. Is a little bit bigger camera, which is quite big, similar to the narrow camera of the LLO, is a small version of that. And we have 2 cameras, and each is independent operated. Is going to provide high resolution image of the surface. And also with DTMPL is a technology demonstration payload, which is supposed to communicate with the spacecraft and ground in certain protocol. Also have the gamma ray spectrometers, which take this gamma ray spectra of the surface of the moon to know the distribution of some major element. And also we have the Kmec, is KPLO magnetometer. It is going to be it was developed by university, and it is supposed to measure the strength of the lunar environment, and then we can map the whole structure. So this shows the timeline and operational payload. So after the launch, there are some stage of the so-called early cruise, and then there is a cruise phase. Depending on the launch date, it could be 70 days or more than 4 months. So, and then rate cruise, and as the lunar orbit acquisition. So we are hoping to operate payload in the TLC transport phase, and also when the spacecraft arrives the commission on the moon, is going to be supposed to be January 1st of 2023. And we have the 1 month commissioning and 11 months of mission phase. So those are the main top time for the payload operation. So if we are lucky to have more fuel, then we are able to extend the mission. And then we got almost more data on using this payload. So this shows that how the orbit and some information of the lunar orbit. For example, the upper left-hand side, there is an inclination 9 degrees, means a pure polar orbit. So you're hoping that the spacecraft are almost like inclination of 90 degrees, and then the altitude of the spacecraft from the surface is more or less around 100 kilometers, but there are some variation. And so in order to manage the spacecraft in certain value, we will maneuver so-called space station keeping maneuver about 5 times for whole years. So we're hoping that space can sustain low in the altitude and can provide good condition for the imaging instrument. So those are the scientific objectives of this mission. First one is we are hoping to construct high-resolution image lunar surface by using the LUTI, ProCam, and ShadowCam as well. And also we are estimating lunar geology and resources and volatiles and major element and physical properties of lunar regolith, weathering process as well. Also, environment of the moon is one of the topic as well. So for the future human mission, we're hoping to map the lunar magnetism, also radiation density, which is crucial for the human mission. So right now, I'm going to show a little bit more information of the, each instrument one by one. For example, first one is the LUTI. It looks like this one. There are two cameras. So each camera is independently work on. So they can be use a backup, for example. So at the 100-kilometer altitude, LUTI give the 2.5 meter resolution. And so so far we confident that those are the good these two LUTI provide much nice image. So SWAT is about 9.75 kilometers. It's not big enough, but still big. So I guess so. So test image show that this was great. So using the LUTI, we're hoping to map some candidate site for the next Korean landing mission. So we selected around about 20 to 30 candidate, as well as some interesting part of not just for the landing, but also lunar science. So those are the topics, the location we are hoping to observe LUTI for 1 year. The ProCam is a little bit different style. So ProCam has have two cameras on it. So it has tilted by 45 degrees from the nadir pointing, and so the original port we are stripped to two direction at the same time, and by measure one of the most important information for the ProCam is gather image with different alpha, so it's called the phase angle. So we have more alpha, then we are able to more observation output and able to induce physical properties. So this is the specification of the ProCam is about 10 degrees of field of view for each camera, about 70 meters ground state resolution, and scale. Because what is 35 kilometers? So basically, it can ship all the surface except for the polar region. So Kmec is instrument developed by university, and it has composed of the boom system and also the magnetic electric part called FCE. So inside the boom system, there are three magnetometers. So using the three magnetometers, Kmec measure the strength of the magnetism, not only from the space, also from the spacecraft itself. So they are willing to subtract the effect on spacecraft by using the three different measurements, so that it could provide more reliable value of the magnetism around the moon. So those are structures, and KJRS is a gamma ray spectrometer. So this is how we are able to observe the gamma ray emission of the moon. So sources are cosmic rays and sunlight and so on. So we are observing those gamma ray emission from there. So this is the spectrometer shape and the specification and test example of the spectra, which we are able to get in using this gamma ray spectrometer. One of the things I want to mention is that this is quite a light spectrometer. It's just about around the 6 or 7 kilometers, so quite small there. And the rest one is ShadowCam. I mean, you guys know well about the ShadowCam is quite similar to the narrowing camera of the KPower mission, but it's supposed to take image which never been so far observed with any cameras on the moon, because due to the darkness of the shadow region, so no camera can take the image so far. But the ShadowCam has much higher sensitivity compared to the NAC camera RRO. It is a couple of hundred times more sensitive, so able to observe the surface inside the permanent shadow region, so that with that permanent shadow region data, it can touch the interesting subject which we so far we don't know that. One of the main information is the albedo patterns and volatile distribution and the structure of the inside the shadow region, so that it's able to provide information for the future global exploration of this region. And this is just a structure of the shadow cam. I want to emphasize one data point here is that the plot here show that the x-axis is the both angle from both sides, and the y-axis is just transmission. So for that, because the shadow cam is intended to observe the dark region. So if there is a light coming outside of the both side, then it's going to be a big problem. So they have to rebuild the optics so that so far it's turned out that the optics in shadow cam is much better than the LRO data. So we're hoping that the shadow cam can image the inside lunar from the shadow region quite well. And on the last slide is the DSN antenna support that because due to the rotation of the Earth, the only one station on the Earth cannot see the moon all the time. So we need at least 3 stations. So KARI has a deep space antenna system in our soil, but also we need at least 2 more ground stations to track the state of spacecraft and get the data. So we have some collaboration with NASA. They are able to provide support to the DSN from Madrid and Goldstone, and sometimes Canberra. Canberra is sort of the backup side of the Yoju because they have the similar longitudes, and we believe that the spacecraft can be tracked all the times, and hoping that everything is going well. So far so good. So hoping that launch is successful and hoping to get all information on starting of next year. Thank you.
Thank you very much, and we wish you all the best in your launch. Is there anyone with a question here in the room? I don't see any online. Here, you want to?
That was an excellent talk. I guess you gave everybody all the information they need.
Thank you.
Well, thank you very much for your efforts, and hope to see you here next time.
Okay, thank you. I hope so.